So you don't need to memorize these, but make sure you have them handy. You're going to need all these log properties. I gave you a bunch as well in the notes last time. The first one right here is basically the definition that you can change back and forth. If the bases match, they cancel. Same thing here. If it's the other way around and they still match, they will cancel. This guy is the change of base. This formula lets you bring down a power. So if you have a power down here, you can bring it in front. If you have a product, you can separate by addition. If you have a quotient, a fraction, you can separate it with subtraction. So make sure you have that somewhere, or just have this open. Okay. All right, so let's look at the homework. All right, so here's right here, there, just the first few questions he's going to ask you. Okay, do you know the name of the property, right? This is the change of base, product property, power property, quotient, nothing insane. Here, they're using the change of base formula. So notice how here you can choose almost any base you want. In this section, they're choosing ln, but you don't have to. You can choose it whatever you like. So here they're asking you to choose a common log. And the only reason you do this is because most calculators do not have base 3. They have the common base and the natural base. So ln and log base 10. So if there's no number there, it's assumed to be 10. Okay. If it's ln, then that's a base e. So this is all base 10, base e, etc. Okay, so if we use the formula, I'm going to write it down. I think it's on the PDF as well. Yeah, check it out. I think it's the fourth one. See how if you have some base and some argument x, you can choose whatever b you want right here. So in number 4, they're asking you to choose base 10, the common log base. That's all they want. Okay, if you use ln instead, then you're choosing the natural base, base e. That makes sense? All right, so this is 8.3. Section is called properties of logarithms. Rewrite the log as a ratio of, part A says common log. That means base 10. So the question they have here is log base 3 of 77. So look at your formula. It says you can change it to any base. I'm choosing base 10. And then the argument goes here. Oops, our argument is 77. Divided by log base 10 of the original base, which is 3. So this is the formula. I'm going to write it over here. Log base a of x is equal to log base b of x over log base b of a. So you can choose any b, as long as b, fits the definition of the function, right? I believe it has to be greater than 1 and no negatives. Okay. All right, part B. This is base E. So change the log 33 of 77 to the ln type. So it's going to be ln 77 over ln of the original base. And then you'll get a decimal once you use your calculator. So nothing crazy. So that's the change of base right here. Okay, I didn't write the title here. Change of base. The first few questions, that's all they're going to ask. Let me show you. Yeah, so you just change it to common, natural, common, natural. You get to here and they just want you to change it to, let's see, whatever base you want, and then punch it in your calculator. And that's really all there is to do. So let's move on to 7, and we actually apply the properties. I assume you guys can punch in numbers in a calculator, so let's move on. Use the log properties on log base 2 of 3/5. So remember, one of the properties is log. Oh, let me switch back. Log of a over b of any base is equal to log of that same base minus of the top one minus the bottom one.
Sir, I have a question.
Mhm.
So referring back to B, when we get the answer, are we typically going to be using the whole decimal, or is it going to be like depending on the question?
Oh, they'll tell you how many decimal points. You're talking about like if they ask you to do the calculator.
Yeah.
Yeah, they should. On that last question I mentioned, number 6, they say 3 decimal places.
Okay.
So on this guy, all you got to do is apply that property. So this would be log base 2 minus the log base 2 of the bottom. That's it. Any questions on applying this property? So you can see right here, number 7, 8, 9, same thing, just apply the difference because it's a fraction. Over here, they have a 45, which can be factored, right? Question says, use the properties of logs or logarithms in terms of log base 2 of 3 and log base 2 of 5. The question they give us is log base 2 of 45. So the good idea is to break it into prime numbers, if you can. So log base 2 of, that's going to be what? 9 times 5 is 45, right? So that's 3 times 3 times 5.
How do we get that log 2 on the calculator?
You can't, that's why you have to use change of base.
Okay,
So change it and then punch it in.
okay.
Change it into something that is on the calculator, like ln or normal log. That's the only reason we bring it up, is so you can use a calculator. Okay, so here you'll get log base 2 of 3 plus log base 2 of 3 plus log base 2 of 5. So every single product will become a sum. Does that make sense? Excuse me.
Actually, I just figured it out too on my calculator. It actually does let me do that.
Oh, cool. So if it lets you put in a base, it'll be the same as not changing it or changing it. It'll be equal.
Okay, but
So
when we
this
actually do
one,
the exam and whatnot, you still want to see the work that way?
if there is a change of base question, yes.
Okay, just making sure.
But it's just a formula. It's not too bad anyway.
Yeah.
Okay, so you separate them, add them together. There's 2 of them, so 2 log 3, and that's it. Any questions on 2 or 3 here? All right, so they'll start to get more and more complicated. So let's move on to something more difficult. Okay, next page. Let's move on to problem. Let's see here, something more complicated. 19 looks weird. Expand the log. So when you expand them, I want you to go as far as you can. It's supposed to be the. X times y to the 4th. Okay. So when you have a power, before you can expand, you got to bring the power down. So step 1 is apply the power rule to bring down your power. So from here to here, I use the power rule. Okay, and then after that, you see the product right here, right? X times y. So that will be ln x plus ln y. So this is the product rule. At this point, we're pretty much done. I guess you could multiply it by 4 or leave it that way. Well, it's all good.
So is that an IN or
I'm sorry?
is that an IN like N or
No, it's ln, the natural log. Don't forget
Okay.
that ln of some argument is equal to log base e of x. That's basically a shorthand for this. Okay. Any questions on number 4? You see what they mean by expand? Okay. Let's do the one with fractions in it. Log base 8 of w squared over v. So apply the difference. That would be log base 8 of w squared minus log base 8 of v. So always do whatever's up top, even if you have multiple terms, that goes first, minus whatever's at the bottom here. Okay, so at this point, there's nothing else to do with this guy, but this has a power, so bring down the power. So now we've expanded as far as we can go. Any questions on number 5?
So I guess the power becomes coefficient.
Yeah, it does. Here
Is
we-
this,
Uh-huh.
sorry to interrupt, is this how the answer is going to be, or are we still going to simplify it?
This is what it's going to be.
Okay,
This is as far as you can expand. I'm going to write the rules that I used each time. So you know. Let's do one more expansion, and then we'll start doing combination. Excuse me. Okay, I'm just going to make one up. X squared y z cubed squared. So there's 3 pieces, and then there's a power on everything. The first thing, you got to bring the power down. Then deal with the inside. So these will be sums. It'll be log of the first one plus log of the second one plus log of the third term. Then bring down the powers. For each single term. So the first thing I did was power rule. Second thing I did was the product rule. Then power again. And then multiply by 2. Any questions on any of those steps there?
We can only do this for logarithms.
Sorry, I can't hear you.
We can only do it. We can only do this with logarithms.
Yeah, you're really far away.
Is fine.
I think his question was if we can only do this with logarithms.
These are all properties of logs. Yeah. So logs become useful when you want to bring, let's say there's a variable up here and you want to solve for it. So you can introduce logs and take advantage of these rules. That's the main reason we're talking about it. One of the many reasons. All right, so now let's move on to combining logs.
So for the natural, we would turn it into a log if it was natural, and then we do the same thing.
All logs have the same properties. Doesn't matter what base it is, if it's 8 or natural, or I'm sorry, common, or the natural. They all
Oh.
obey the same rules.
Okay, so you would still bring down the powers.
Yeah.
Okay, cool.
So they ask you to expand, you go as far as you can, bring on all the powers, break up the products and break up the quotients if you have them. So that's as far as you can go. So now let's move on to combining logs. So this is going one direction, breaking them apart. Now put them back together. Like, can you turn something like this into this? All right, let's see here. Let's pick something simple. Log base 4, 7x minus 9 log base 4 x. Or you can only combine them that if they have the same base. So they both got to be 4 or 2 or common or natural. Otherwise, you can't do anything. All right, so since we have minus, well, actually, before you apply a product or a quotient rule, you have to deal with coefficients. So you can't use the product or quotient unless you have unless you've gotten rid of these numbers. So the first thing you got to do is change it to a power. Once you have it as a power, change it into a quotient. So this is the power rule in reverse. Then use the quotient. So this will become whatever's on top minus means divide by whatever's on the bottom. This is the quotient rule in reverse. Any questions on number 7? Okay. Let's do this ugly one at the end. Oh, the instructions would be combine the log. Okay, so this would be 2 times 2 ln x minus ln of x plus 5 minus ln of x minus 5 So before you start, make sure you multiply everything out. So get rid of that 2 in front. So that'll be 4 times 2 times 2. So distribute the 2. Gets us to here. So we haven't done any log rules yet. Once you gotta get rid of all these coefficients, change them to powers. That's the first thing we gotta do before we do the product or quotient. Now they are all up top, so use the quotient. So I recommend doing it 2 at a time, that way you won't make a mistake. So this minus that means this first part goes on top, this goes on the bottom. Minus this one, do the same thing. So this goes on the bottom. Okay, any questions on how we combine that log? So the point of this section is to get comfortable with all the properties. So breaking them apart, putting them together, and using your algebra to help you.
I have a question.
Yeah.
Can we do number 25?
25, sure, yeah. This is an expand. So the first thing you gotta do with this guy is change that root to a power. So that's yz over x to the 8. So this becomes ln of yz over x to the 8 to the 1/3 power. Right, same thing. Then bring down the third, and then start the log rules, or the other log rules. So that's the power rule. So now we're going to apply the quotient. So whatever's on top minus whatever's on the bottom. That's quotient. Then apply the product on this one because you have a y times z. So this will become ln y plus ln z. And then you have that power, so bring down the power. I ran out of space, so I did 2 rules at once. Hope that's okay. Then you can multiply the third, or you can leave it there. Either way is fine, but do you see how we expanded everything?
Yes.
Okay. Right. Well, that's pretty much it for 5.3. And just get comfortable with the rules and use them. That's it. 5.4. They're gonna assume you're comfortable and you're gonna solve equations. Let's check though. Yeah. So we're going to use the rules from 5.1, 5.1, and 5.2. and what we just did right now to solve equations. So 5.4. Exponential and logarithmic equations. All right, let's pick some examples here. So we're going to need all the properties on that sheet, but also the ones from last time. So recall that we said if log a to the x is equal to log a to the y, then that means that x is equal to y. So you can change, you can go from this equation to that one, or you can go from here and introduce a log of your choosing, which is pretty helpful. We also said that if you have a exponential, some base to the x equal to some base to the y, then that means that you can set these two equal to each other. Or you can introduce a base and change them into exponential, which is useful. So you remember these plus the ones that are on the sheet. We're going to use all of them. Let's start with something simple where we don't have to use too many properties. No, it's too easy. Let's see here. So let's skip to number 5 on your homework. So you can use property 2 to solve this, or you can use all your log properties we just talked about. Remember how we said you can, if you have an equation, which we do, then you can introduce any log you want. If you already have a log that are equal, you can set the arguments equal to each other. So I'm going to go from this direction to here. I'm purposely going to choose ln and do it to both sides. Then I'm going to bring down the x because I need to solve for x. So from here to here, introduced ln on both sides. You can choose any log. I chose that one just because it's on the calculator. At this point, ln 1/2 is just a number, so divide it out. This is like, I don't know, negative point whatever. I don't know, I help in. ln 8 is just some other decimal. Nobody cares. So x is equal to this number. So instead of using all those properties, I just introduced logs and solve for x. You could have used the properties instead because it's an easy question, but I use this technique because this works every single time and I don't have to think too hard. So at that point, you just divide ln 8 by ln 2, no, actually 1/2, which is -3. So this is actually just -3. So I solved it using a log that I introduced. Then I did the power rule right here. Then I just did algebra to solve for x. So here's an alternate method. This is the way they wanted us to do it. What I'm gonna do over here. But any questions on what we just did? Do you see how we took advantage of our log of the log properties? Is it okay?
Yes, yeah.
Okay, so do we start over and say, you know what? 1/2 and 8 have the same base. So you should be able to match them. Right, this is technically 2 to the -1, right? Do you agree? 1/2. And 8 is 2 cubed, right? Now they match. So this -1, when you have a power raised to another power, you multiply them. And when you have bases that are the same, you can just say, you know what, that means that -x is equal to 3. Solve for x. So when you are able to match the bases, this is what you're supposed to do. But this only works if you can change them, if you can force them to match. What if this was like a 3 and this was a 7? So now we're going to be the same, right? So here I use rule 2 because I got matching bases. That's why I prefer you just think of it this way, because this will always work. It doesn't matter if they match or not. And then your calculator can handle this part, giving you whatever they're going to get. Any questions on number 1? Okay. That's our first exponential equation. Let's do the first logarithmic equation. So I'm going to do it 2 different ways. I'm going to use the log properties to solve for x. So here we have a difference. So you agree that we can combine them as a product, right? At that point, you can introduce a base that matches the ln to cancel it. So you can say, you know what, I'm going to use rule 2. I think it was 2. Yeah. And so, you know what, I'm going to bring down a base and make this into a power. So these will cancel. If you look at your formula sheet, when they match up, right, b to the log b, so if they're the same, you're left with the argument. E and ln are the same base. They're inverses. So they cancel out, leaving me with this. E to the 0 is a 1. Divide by 5. And x is a 5th. Oh shoot, I messed up. Difference is division, not product. Dang it. I was like, something's not matching up here. When you subtract, you get x over 5. X divided by 5 because it's minus. Which means you'd have to multiply both sides by 5, which would give us 5. So this is the method I want you to do. I want you to use every single time because it will always work. So you combine all your logs, introduce a matching base, cancel the log, solve for x. The method that they might show in the examples, they're going to show you both, but we could have used the definition and say, you know what, these are the same base. So set the arguments equal to each other, which seems super easy, right? But that only works if they're exactly the same. Okay. So use your definition whenever you want, but just remember that sometimes you'll be forced to use your properties. And that's just how it is. So you choose whatever method you want. Just remember, this one will not always work, just like the other one. Any questions on number 2? All right, let's pick another one. Something harder, I guess. Yeah, this one here. This one you have to solve this way. 4 times 3 to the x equal to 20. I want to solve for x. So first thing you do is get this, isolate the exponential part. Divided by 4 on both sides, that'll give us 3x equal to 5, right? Let's skip a step. Divide by 4. Then introduce whatever log you want. I like ln, so I'm going to keep choosing it. Just make sure you're able to use it on a calculator. So I recommend ln or just the basic log, the common log. Once you've done that, bring the variable down. That was the power rule. After I've introduced logs. So divide by ln3 and you're done because ln3 is just a number. So who cares? So x will equal ln5 over ln3, which is some number. This time they want us to find out what that is. So that will be ln5 divided by ln3. So 1.465. They round to 3 decimal places. Any question number 3? Okay. Oh, yes, we got the homework. All right, so these are not too bad, so I'll let you do those. This guy, we'll do that next. And 13 looks, so we'll do a harder one. Example 4. In this section, all we're doing is solving. So 3e to the x equals 94. So divide by 3. So e to the x equals, I don't think 94 is divisible. Let's see. No. So I need to cancel e. So the inverse of e is ln. So introduce ln on both sides to cancel the e, and then you have solve for x. If they want a decimal, you have to punch this into your calculator. Any questions on 4?
So what do you do with the E?
What's that?
What did you do with the E?
It cancels because ln and e are inverses. So right here, the property that happened was this. If they match, right, you get whatever's up here. So ln and e is this scenario. Just remember, what is ln? That makes sense?
Yes.
Okay. Let's do another one. 3 minus 7e to the x equals -4. Okay. So subtract the 3. Divide by -7. We get to here. Right. I didn't show the -3. So -3 on both sides here. Gets us to here. Divide by -7 gets us to here. So now we need to cancel the e. So introduce ln on both sides. So these are gone. ln of 1, last time we said the logarithm of any, 1 at any logarithm is going to be 0. That's just by definition.
It's the same true if it was -1.
No, it's
Yeah.
undefined -1. Logarithms domain is only for numbers greater than 0. It's like a square root kind of,
Oh, okay.
except square root's cool with 0. This one is not. Has to be greater than 0. Alrighty, let's do one of these weird quadratic types. Any other questions on number 5? Okay. Let me know. Notice how this is a quadratic type of equation. This is the same as e to the x squared. Do you agree? E to the 2x is the same as e to the x squared. Using our properties of exponents. So if I let e to the x equal to some dummy variable, it becomes more obvious that this is a quadratic, right? Does that make sense?
And we could pick any dummy variable, right?
Yeah, it doesn't matter. It's just a temporary placeholder. So factor this guy and find out what W is. W is going to be factors of -15 that add up to -2. So -5 plus 3. So W minus 5 is equal to 0. W plus 3 is equal to 0. W will be 5 and -3. But remember that those are dummy variables. So we're actually trying to solve for x. So change it back to the x value. Do you see any issues here? Then what's the domain of, or the range of e to the x? Do you remember?
Is that 0 to infinity?
Yeah, if you graph it, it's never negative. But you should know just by looking at it that that has no solution. And if you didn't know, graphing it would show you that you have no negative y values. You see how it's always above the y-axis or the x-axis? So if that's true, then how does this have a solution? So if you try to solve for it, you will get an error, even if you didn't notice. So when you take the ln of both sides, this cancels and you get ln 5, which is some decimal. If you did it here, you should see that I cannot plug in a negative. This has no real solution. That's it. And that's your solution. We only have one. You do not have two. If they say rounding, then plug this into your calculator. If they don't say anything about rounding, or if they say the word exact, plug this in. That's your answer. Any questions on this quadratic type of exponential? Let me turn the page. Make one up for you. That's harder. Then we'll move on to log equations. Let's say this was 2 to the x plus 3 equal to, I don't know, 3 to the x, 2x plus, what am I supposed to? So I'm going to have to introduce ln right away on both sides, or some logarithm. Bring down the power. In front of the logarithm. Multiply the logarithm out, that'll be ln times these two terms. That'll give me x ln2 plus 3 ln2 equal to 2x ln3 plus 2 ln3. Everyone's still with me from here to here. So right here I did the power rule. But here I introduced ln. Then I did some algebra, got me to here. So we're solving for x, right? That's what we're doing. So move anything with an x on one side. So I'll move this one over here and this guy over there. So that'll get me to here. Subtract this one over there. Gets me here. Factor the x in order to solve for it. That'll give me ln2 minus 2 ln3 equal to this thing. Remember, this is just a number. It's not a very pretty number, but it's a number. So is this. This is like the number 7.8. I don't know, some nonsense. So divide that thing out to solve for x. So this is my x. Okay. So that'll be similar to number 15, kind of. So let's move on to log equations. You have any questions on exponential equations? Good. All right, good. Just let me know. Try to do as many as I can. So you have some examples. When you're solving log equations, you have to check your solutions because sometimes they don't work. That's the crappy part. ln x plus ln x plus 1 equals to 2. So we got to solve for x. But the x is inside those logarithms. So when you're solving log equations, combine them into one using your log properties from last section. Once you have one single log, introduce the base that will cancel your log. So I'm going to introduce e on purpose. We got to do it to both sides. So the e's and ln will cancel because they're inverses, leaving me with x squared plus x equal to e to the 2. Okay. Did I make a mistake? That sucks. It's not that it's wrong, it's just that this question is horrible. Do you see what we got to do? Life sucks. We got to do a quadratic formula with this weirdo number the whole time. Trying to see if there's a shortcut because I don't like that at all. Product. No. Oh well. Okay. So quadratic formula says negative b plus or minus square root b squared minus 4ac over 2a. Okay. So that will be negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative e squared over 2 times 1. It's calculator times what that means. Negative 1, let's make it pretty. Negative 1 plus the square root of 1 minus 4 plus, actually plus, because negative times negative is positive, so that'd be plus 4 E squared. Okay. And then the other solution would be minus. So those are the two solutions. Right, they tell us around 3 decimal places. So that will be 2.264 and negative 3.264. Okay. Do you see which one works? Yeah, remember I told you you have to test them for logarithms. This should be ruled out right away because you cannot plug it into this ln here. Plugging in negative 3.264 would be outside the domain. So right away you can rule this guy out. So the only one you have to really test is this one, but that's fine. Any questions on this problem? I don't know if it's going to be a weird question, but oh well. That was number 20 in your homework. Okay. Let's do another one. (23) log base 3 plus log base 3 of x plus 5 equals to log base 3 of x plus 21. So this will be log base 3 of x times x plus 5. So combine all the logs on both sides if you have them. So this will be log base 3 of x squared plus 5x equal to log base 3 of x plus 21. So now introduce the base 3 to cancel log base 3. So these are gone, leaving me with this, with the arguments. You have a quadratic, so set it to 0. Factor. Factors of 21 that add up to 4.
7 and 3.
But it's a positive 21. Oh, that's the issue. It's negative. Okay. Yeah, plus 7 minus 3. So x plus 7 equal to 0. X minus 3 equals to 0. X equals negative 7. X equals 3. Can I use the negative 7? If you plug it into any log in the original and it results in a negative, then you cannot use it. You cannot use it. So negative 7 plus 5 is negative 2, right? Negative 7 straight up is also negative, so I can't use this. I only have one answer. If you don't see it, just plug it in and see if you get an error. In your calculator, plug in -7 all the way through. If you get an error, can't use it. Can't use that solution. If you plug in 3, you will get the same thing on both sides, which makes it a solution. Okay. I'm going to delete that last question there. That was weird. I'm going to give you more time on chapter 5. I know it closes Sunday, but this chapter is a little more challenging. So I'll make sure to extend a little further. And I'll post the videos in just a second. Or the module and the video, of course. You guys have any questions on 5.4 and 5.3?
When we do our test, are we gonna, can we use the calculator for some of the questions, especially if they're doing with the
Yeah,
when
yeah,
quadratic
that's
equation?
totally fine. You can use your calculator, just make sure you show your work, and you'll be fine. Just scientific should be fine. If you really want a graphing, you can use it, but you don't need it. Up to you. I'm going to delete. Let me see here. Let me stop the recording there.